All right, folks, what we are learning today is how electrons are placed in the atom. In regular chemistry, we learned that the basic shape of an atom has a nucleus in the middle, and then the electrons orbit the outside of the atom. Okay, this is the very basic concept of what the atom looks like. And as it turns out, as we are learning in AP chemistry, things are a little bit more complicated than that. So the first thing we need to talk about is this guy named Niels Bohr. Okay, Niels Bohr came up with a model of the atom that looks more like this. It's got the nucleus, and then it's got several levels of like shells of electrons, okay? And if you guys remember in our discussions, each one of these shells corresponds to a row on the periodic table. So like this would be your first shell, second shell, third shell, and so on. So he was getting closer to the correct answer. He also noticed that you can actually put an electron. So if you have an electron, for instance, on this innermost shell, if you give that electron some extra energy by like sending electricity through it or anything like that, you can actually make this electron jump up in energy levels. Okay, and when that happens, we call that the excited state. Oops. And it'll buzz around there in that excited state for a little bit, and then it will lose its energy and then drop back down to what we call the ground state, where it originally was located. Okay, so this concept of the excited state and the ground state is what helped Bohr to establish this model of the atom. And he wasn't entirely wrong about this. This is very close to the truth of what the atom looks like. There are definitely these energy levels that exist within the atom. However, there's one more layer to it, and this guy named Erwin Schrödinger figured out the rest of the puzzle. Okay, so he came up with a wave equation. You can learn more about that if you want later, but it's not on our list of things we have to learn. But he described our energy levels as we know them now. So again, he does agree that each row on the periodic table represents a shell of electrons. However, within each shell, there are sublevels. Okay, and these sublevels have letters S, P, D, and F. Okay, so you guys can think of this as like a hotel. Okay, and each floor of a hotel is a different shell of electrons. Okay, and so like this would be your first floor, second floor, third floor, and so on. And on each floor, you can have standard rooms, or you can have premium rooms, or you can have deluxe rooms, or you can have like a fantasy suite. Okay, so essentially it's like the different places that you can occupy on each level. Okay, so S, P, D, and F. Also, each sublevel contains orbitals where electrons are likely to be found. So these orbitals are like the paths that the electrons take as they're orbiting, because as it turns out, they don't actually orbit all of them in a circle. Okay, so again, these can be imagined as like probability clouds. So if I said, hey, find me an electron, you would find electrons in orbitals, more likely in the paths of these orbital paths. So we'll talk about what they look like. So the S sublevel only has one orbital. And it is a spherical shape. So it's shaped like a sphere. Okay, that's like if you had this hotel idea, right? The standard room is just one room. Okay, meanwhile, the premium room is actually a suite of 3 rooms. There are 3 orbitals. So there are 3 different paths an electron can take in the p orbital, okay, or the p sublevel. Next up is the Ds. The Ds, think of like deluxe rooms. Okay, there are 5 orbitals in the Ds. Okay, By the way, the p orbitals are like dumbbell shaped or like infinity sign shaped. Okay. The d orbitals are even more complicated, and you don't have to know their shape after that. So we're just gonna say that they exist. I won't tell you their shape. I'll show you a picture of them. They're goofy. And then the F is the most complicated. Instead of 5, they have 7 orbitals. Okay, so in terms of where these things are located, when it comes to describing the atom and where the electrons are located in the orbitals, we actually have a way to make it easy to understand. First, I want you guys to realize that for this example, or for what the topic that we're talking about, helium lives over here next to hydrogen for these examples that I'm talking about. So we're just going to ignore helium and put it over here next to hydrogen. And then the different parts of the periodic table help us describe the different orbitals. Okay, and I know this doesn't make a whole lot of sense yet. Just stick with me and label things along with me. So you've got the S, I'll use a different color. The D's are located here. And then the P's are located here. And then I need a different color. Let's do the F's are here. Okay. Another thing you should label is the numbers of the shells. So this is shell number 1, 2, 3, 4, 5, 6, and 7. Okay. And then something important that you need to just memorize is that after you go through the S section of the 4th shell, all the D's are shifted down 1 row. So what I mean by that is that this is the 3rd shell, 4th shell, 5th shell, and 6th shell. And I will explain why that happens in a second, but just stick with me here. And then when you get back to the P's, it continues as normal. So this is the 4S section right here. And then over here is the 4 P's. However, this is the 3 D's. Okay. And like this is the 4 D's and so on. And then also confusingly, but just please label it, this is the 4th shell and this is the 5th shell. Okay. So there is a reason for that, I promise. Just stick with me here. Okay, so let's see. So keep in mind also that each orbital can hold 2 electrons. So something I want to point out, okay, something that'll hopefully start making sense. Each orbital can hold 2 electrons. The S sublevel only has 1 orbital. Take a look. For the first shell, the S orbital is 2 things wide. 1 orbital, 2 electrons, 2 things wide. Okay. Meanwhile, the P sublevel has 3 orbitals. 3 times 2, that means 6 electrons can be held in it. And look at this, 1, 2, 3, 4, 5, 6. This is not a coincidence. Meanwhile, the D sublevel has 5 orbitals. Each can hold 2 electrons. That makes 10. And look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the F sublevel has 7 orbitals, holding 2 electrons each. So 7 times 2 is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again, not a coincidence. Okay. So the reason that these are shifted, okay, the reason the shells are shifted, I want you guys to notice that as we add shells of electrons, we get more sublevels available to us. So take a look. In the first shell, the only thing we have is an S sublevel. That's it. Then onto the second shell, we have an S and we have a P. Okay, now we get to the third shell. In the third shell, we have an S, we have a P, and then we have a D. Okay, and then after that, on the fourth, we have an S, we have a P, we have a D, and we have an F. Okay, and theoretically, if there were more electrons to locate within the atom, we would add more sublevels. But as it turns out, with just having these 4, we can place electrons everywhere they need to go. Okay, but that's why their order is the way it is. Okay, let's see. Okay, another thing that might come up that you might need to know is something called the Aufbau principle. And the Aufbau principle states that electrons fill the lowest available energy level before occupying a higher energy level. And this is a nice little graph of the different energies that each level has. So the 1s's are going to be the smallest or the lowest energy, followed by the 2s's, followed by the 2p's. And after 3p, we get 3s, and then 3p, and then 4s, and then 3d. So if you guys notice, the 3d energy level is actually higher in energy than the 4s. And before you're like, oh my God, how am I going to remember all of this? It's actually spelled out for you right here on the periodic table. Take a look. After 4s comes 3d, and then back to 4p, and then 5s, and then 4d, and then 5p, and so on. So the order in terms of increasing energy is as written with these labels on the periodic table. So you don't have to memorize anything except for the shell numbers and the S, P, D, and F. Okay, so what on earth does this mean? First of all, again, I wanted to show you what the shapes of those orbitals look like. Here's your S orbital. There's one of them, right? Here are your P orbitals. There's 3 of them. Here are your Ds. There's 5 of them per atom. And so they're like double dumbbells, kind of, right? This one is like a donut in the middle, okay? And then these are your Fs, and the Fs are just wonky, okay? You do not have to memorize the D and the F shapes. You just need to know the S and the Ps, okay? So I've had questions, Miss O, how does this actually look when you're building an atom? So let me build it out for you guys, okay? Like we said, here comes the nucleus. The nucleus, the first shell is going to have an s orbital, and that's it. So here's its spherical s orbital. Let's go to the next shell. The next shell is going to have an s orbital as well, along with 3 p's. And so I'm going to my p's again. I have 3 orbitals in my p's, and they're shaped like dumbbells. So here's the first one, and then the second one, and then the third one. Okay, so that was my second shell. My third shell has an s orbital. It also has 3 p's, 1, 2, 3, and then it also has d's. Okay, and it has 5 d orbitals. So this is what its d orbitals would look like. And again, 5 of them, right? So 1, 2, 3, 4, 5. And if you guys notice, it's starting to look pretty chaotic, but that's the way this works. They all layer on top of each other, okay? So this is more accurate to what the pattern of orbit looks like for the atom. Okay, if you've stuck with me so far, let's take a look at how we actually address these things in terms of placement of each electron, where it is on the atom. So when you're trying to describe where electrons are located, we use something called electron configurations, okay? It's sort of like an electron address. It literally tells you exactly where each individual electron is located within the atom. So let's start easy. Let's describe where the electrons on hydrogen are, okay? So here is my periodic table. You might want to pause and do this to your own periodic table. So this was, again, the third shell. Ooh. The third shell, 4th shell, 5th shell, 6, and then this was 4 and 5. So you might want to pause and label the S, P, D, and F sections along with the shell numbers. It's up to you. So let's take a look at hydrogen. Hydrogen is, hydrogen, okay. Hydrogen is located in the first shell in the S section, and there's only 1 electron there. So first shell, S section, first electron. That is the location of its electron. So 1s1. Easy peasy. Let's do helium. Helium, remember for the purposes of this, helium lives next to hydrogen. So helium has 2 electrons, okay? And let's see, helium is in the first shell, S section, and there's 2 things located there. So first shell, S section, we go through 2 things. So this is telling us that helium has 2 electrons in the 1s section, okay? So there you go. So 1s2. On to lithium. Let's take a look at lithium. Lithium is located here. I want to remind you guys that lithium has 3 electrons. So we have to account for where all of the electrons are on lithium. So we have to start at the beginning because lithium has all 3. We have to start where all of lithium's electrons are. So here's the deal. For lithium, what we want to do is basically go through the periodic table and stop where lithium is. So in order to get to lithium, we're going to go through 1s and 2 things. So 1s2. And then we go down to the next row, second shell, S section, first thing. Second shell, S section, first thing. So here are lithium's 3 electrons. There's 2 in the 1s section, and there's 1 in the 2s section. So these high numbers up here should add up to the overall number of electrons on lithium. So 1s2, 2s1. Okay, let's do boron. Boron is located here. It has 5 electrons, so we need to describe where each electron is. Again, the trick to this is basically, again, start at the top and go through everything until you stop at boron, okay? So to get to boron, we're going to go 1s2, and then 2s2, and then over here, so we're going to keep going. This is the 2p section, okay? So it's going to be 2p, and it's the first thing. So 1s2, 2s2, 2p1. Okay, so we went through the first shell, S section, 2 things, that was this. Second shell, S section, 2 things, that was this. And now we're still in the second shell, P section, first thing, and that's this. Okay, so that's borons. 1s2, 2s2, 2p6. Okay, well, let's do neon. Neon, I'm running out of space here. Let's go. Okay, neon has 10 electrons, and to get to all electrons for neon, we're going to go through 1s2, and then 2s, oh my dear, 2s2, right? So 2. And then we're going to keep going through here, and to get to neon, we have to go through 1, 2, 3, 4, 5, 6 things in the P section. So it's going to be 2p6. Okay, I hope this is clicking for you guys. So 1s2, 2s2, 2p6. That's neon. And again, neon has 10 electrons. Look at this, 6, 7, 8, 9, 10. There they all are. Okay, titanium is next. Here is titanium. Okay, so here's the deal for titanium. Remember, this section right here belongs to the 3 Ds, okay? So to do titanium, it's going to be Ti. Okay, and then we're going to go through everything and stop at titanium. So it's going to be 1s2, 2s2, 2p6. And after 2p6, we go down to the next row. Now we're at 3s2. And then keep going. Now we're in the 3p6. After 3p6, so after here, we go down to the next row. This is the 4s2. And after 4s2, immediately after 4s2 comes 3d, and titanium is the second thing, so 3d2. Okay, so there you have it. That is titanium's electron configuration. I'm not going to copy that over here because I feel like you can see it over here. Okay. So bromine. I want you to go ahead and pause and do bromine. Okay, bromine is right here. See if you can do it on your own. And then unpause and I'll show you the answer. So if you guys did bromine correctly, you should have said 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, where are we at? 3d10, and then 4p5. Okay, that's what you should have done for bromine. If you're feeling confident, go ahead and pause and try yttrium. Go ahead and pause and try yttrium. If you did yttrium correctly, you should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and then we ended after 5s2, we go through 4d1. Woo! Okay. So I think you guys are getting it. Here comes the last level of difficulty with this. Whoop. Okay, I want you guys to notice something right here. Do you guys notice? On this periodic table, we go from number 56, and we have this strange little gap, and then 72. Okay, in all the other ones, we go like 37, 38, 39, 48. We keep counting. There's a gap here. Why is there a gap here? There is a gap here because technically on the periodic table, this should be cut. And this whole thing should be placed in this little space right here. So it technically, this should be a really long periodic table. And after 56, you would go 57 through 71, and then pick up at 72 and keep going. And then 86, 87, 88, and then 89 through 103 and keep going. So basically this section should live in this little space right here. Okay, we don't do it because it's hard to fit on a piece of paper if it's really long. So they just cut those and put them at the bottom. Okay, what this means for us when we're writing electron configurations is that after you get through 6s, you have to go down here and go through the 4f's. Okay, and then we're back up here and you can go through the 5d's and so on. Okay, so the pattern goes 6s, 4f, 5d, 6p, 7s, 5f, 6d, and then you finally end at 7p. Okay, and this is the very end of the periodic table. Okay, so just keep in mind that at the space you jump down. I feel like your periodic table might look a little different. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ugh, I hate when this happens. So sometimes they put 15 down here. I don't know why they do that. It's really frustrating. So technically LU and LR should live in this little space right here. Okay, so yeah, LU and LR. So this should be where LU lives, and this is where LR should live. It's very frustrating, and I hate it when they do that. But anyway, some periodic tables look different. But yeah, these guys technically live here, just FYI. Okay, so the F section ends here, and then these guys are technically part of the Ds. Okay, the reason it gets a little goofy is because these energy levels get so close together up here. If you look the 7s, the 6p, these are really close in energy level. And so things get a little wonky. There's some exceptions that you don't have to know. But yeah, okay. So let's take a look at europium then. Okay, europium is located right here. Okay, there's europium. So it's in the 4f's. So let's go ahead and figure out what the electron configuration for europium should be. And I'm just going to say it out first, and then we'll write it. So europium is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, and then we jump down to 4d, and what is that going to be? 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. Yeah, 4d7. For F7, sorry. So let's go ahead and write that out. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, and then 4f7. Whew. Okay, I think you guys are getting it. Go ahead and pause and try tungsten and lead really quick. Go ahead and pause and try tungsten and lead really quick. Okay, these are the answers for tungsten and lead. Go ahead and pause, see if you guys did that correctly. Now, these things get really complicated, and who wants to write all of this, right? This is so much. So instead, there is something called the noble gas shortcut that you can do. For the noble gas shortcut, let me show you. For chlorine, what you want to do, let's say if we're doing chlorine, chlorine is located here. You want to find the noble gas that comes before chlorine. So remember, guys, this is the noble gas column, okay? This guy right here. So for the noble gas column, the one that comes before chlorine is neon, okay? So what we're going to do is put neon in brackets. Okay, and then we only pick up from after neon. So after neon, to get to chlorine, we go to 3s2 and then 3p5. So it's way, way, way faster. Okay, so for selenium, let's see, you're gonna do, selenium is right here. Okay, so the noble gas that comes before selenium is argon. So we're gonna put argon in brackets and then pick up from there. So it's gonna be argon in brackets and then 4s2, 3d10, and then 4p4. And I already forgot what I said. What did I say? For selenium, 4s2, 3d10, 4p4. Okay. Go ahead and pause and see if you can do molybdenum on your own. Molybdenum is located right here. If you did that correctly, you should have had krypton in brackets. And after that, you would have 5s2, 4d4. Okay, so there you have it. That is electron configurations.